Here we have an infinite series of 1 dividing by n plus 1 times n plus 2, and we want to show that this infinite series converges to 1 half. And so the first thing we want to do is use what's called partial fraction decomposition to decompose this expression right here. And so the this fraction is equivalent to the expression 1 over x plus 1 times x plus 2, and we can write this as some constant a dividing by x plus 1 plus some constant b dividing by x plus 2. To combine these two expressions, we can cross multiply, so it would be a times x plus 2, and then plus b times x plus 1, dividing by the product of the two denominators here. So what this means is that 1 is equal to all of this. And this equation right here is true for all x, for any x. And so first, to find a, we can let x be negative 2. So when x is negative 2, then we have negative 2 here. This part will be 0, and then negative 2 plus 1 is negative 1. So we end up with b is equal to negative 1. And then to find b, we can find a, we can let x be negative 1. The reason we want x to be negative 1 so that this part is 0. So in the place of x, we have negative 1, so this part would be 0. And then here we just get 1a, so a is 1. So a is 1, b is negative 2. So 1 over x plus 1 times x plus 2 is the same as 1 over x plus 1 plus negative 1 over x plus 2. So we can rewrite 1 over n plus 1 times n plus 2 is 1 over n plus 1 plus negative 1 over n plus 2, which is simply 1 over n plus 1 minus 1 over n plus 2. And here's our original infinite series, which now can be rewritten as as 1 over n plus 1 minus 1 over n plus 2. And these are called partial sums. And so this is the sum of the first 10 terms. So this is term number 1, number 2, and number 10. And we add all these together, we get 0.41666666. And then this is the sum of the first 100 terms. It is about 0.49. This is the sum of the first 1,000 terms, which is 0.499. This is the sum of the first 10,000 terms. It is 0.4999. And then this is the sum of the first 100,000 terms, which is about 0.49999. And so once again, these are called partial sums. And so we can see that the sequence of partial sums is approaching 1/2, as n approaches infinity. And so now let's find the sum of the first k terms. So this is the first 10 terms. This is the kth term. So in the place of k, in the place of n, we just have k. And then the term before the last term here, in the place of n, we have k minus 1. So in the place of this n right here, we replace it with k minus 1. So we end up with k and k plus 1 here. And for this term, replace n with k minus 2. For this term, replace n with k minus 3. And then here, replace n with k minus 4. And then this term, replace k with n minus 5. And then we can see that this negative minus 1/3 and 1/3 now will cancel out, and these two will drop out. The minus 1/7 and the 1/7 here will drop out, and these will drop out. And then eventually this will also drop out. And then down here we can see that the minus 1 over k plus 1, that will drop out. And then these right here will cancel out. And then eventually this term will also drop out. So what's left is just 1/2 minus 1 over k plus 2. So this is the sum of the first k terms. And here's our original series, which is the same as the series 1 over n plus 1 minus 1 over n plus 2. This is the sum of the first k terms, and if we allow k to approach infinity, then we get the entire infinite series. So this infinite series is the same as the limit of s of k as k approaches infinity. But s of k is 1/2 minus 1 over k plus 2. As k approaches infinity, this term approaches 0. So we get 1/2 minus 0, which is 1/2. And so we say that the original series converges to 1/2. And that's the end of the video.